In this segment, we'll explore the practices surrounding cloud service accounts, focusing on two prominent examples: Google Cloud Platform's service account impersonation and AWS's AssumeRole. These mechanisms are fundamental for managing permissions and identifying resources across different cloud environments. Understanding the distinctions between these two is essential for crafting secure cloud security policies, as well as for effectively managing identity and access management, IAM, within your organization. In this slide, we dive into the distinctions between GCP service account impersonation and AWS AssumeRole, both vital components of cloud security and IAM policies. Understanding these differences is essential for anyone preparing for cloud security certification exams. These concepts form a foundation for managing identities and controlling access within cloud environments, ensuring that applications and users can perform their tasks securely and efficiently. This understanding not only enhances your ability to implement robust security measures, but also strengthens your proficiency in cloud security assessments. GCP service account impersonation is designed to enhance security by allowing applications and users to assume identities with specific permissions without sharing private keys. This mechanism utilizes OAuth 2.0 to provide delegated access, ensuring a secure and robust approach to identity management. It enables finer granularity in access control, allowing you to define and manage permissions more precisely. This mechanism is particularly beneficial for managing cloud resources securely, making it a key concept for cloud security and IAM policy development. In this slide, we focus on the specific G-Cloud commands related to GCP service account impersonation. To set a target account for impersonation, you would use the command gcloud auth activate service account impersonate per service account equals service account email. This prepares your environment by activating the desired service account for impersonation. Once the target account is set, you can execute commands with impersonation. For instance, to list compute instances under the impersonated account, you would use gcloud compute instances list -impersonate service account service-account email. These commands highlight the practical steps for leveraging service account impersonation, ensuring you can operate with the appropriate identity and permissions without needing to manage private keys directly. This approach enhances security by providing fine-grained access control. In this slide, we are discussing the basics of AWS AssumeRole. The primary purpose of AssumeRole is to enable trusted access to AWS resources. At the core of its functionality, AssumeRole leverages the AWS Security Token Service (TS) to facilitate this access. One of the key points to note is that it generates temporary and time-limited credentials, enhancing security by ensuring that access is only available for a limited period. Additionally, AssumeRole supports cross-account access, allowing you to securely access resources in different AWS accounts without sharing long-term credentials. In this slide, we focus on the practical aspect of using AWS AssumeRole with the AWS CLI. Here, we explore the crucial commands necessary to assume a role via the AWS command line interface. First, the command AWS STS AssumeRole role session name is used to leverage the AWS Security Token Service in assuming a role. This command is vital for generating temporary, time-limited credentials, allowing you to access AWS resources securely. Following this, you need to configure the AWS CLI with the assumed role by executing AWS configure set role-arn. This step ensures that your AWS CLI operates under the security context of the role you've assumed, facilitating secure cross-account access. Understanding and executing these commands effectively enables you to harness the capabilities of AWS AssumeRole, meeting the access needs within your organization. On this slide, we are comparing the security and practical use cases of GCP versus AWS. When it comes to GCP, it offers the ability to act directly from a service account, which can simplify internal microservices communication and reduces the risk of key mismanagement. On the other hand, AWS leverages session-based temporary credentials, which help limit credential exposure, making it suitable for cross-account access within organizations. This session-based approach in AWS can add a layer of security, as it minimizes the risk associated with long-term credential storage. Each platform provides distinct advantages depending on your use case and security needs. On this slide, we focus on practical application tips for both Google Cloud Platform and Amazon Web Services from a security and management perspective. When working with GCP, it's important to regularly review service account roles and permissions to ensure they're in line with the principle of least privilege. Additionally, implementing logging for actions taken with impersonated accounts can provide visibility and auditability, helping to prevent unauthorized access or actions. For AWS, monitoring AssumeRole activity via CloudTrail is an essential practice. This allows you to keep track of the usage of temporary credentials and the assumption of roles, which is particularly useful in identifying unusual or potentially unauthorized activities. Furthermore, implementing multi-factor authentication, MFA, adds an extra layer of security, making it more difficult for malicious actors to gain access. Now, let's examine a real-world scenario to better understand the application of identity management within cloud environments. Consider Company A, which utilizes Google Cloud Platform, GCP, for managing its microservices. To facilitate seamless internal API communication, they employ GCP impersonation. This approach allows them to efficiently manage identities without compromising security. Now, in terms of best practices, when working with GCP, it's essential to apply the principle of least privilege. This means granting only the necessary permissions needed to perform a task, thereby reducing the risk of unauthorized access. On the other hand, for AWS, it's important to regularly rotate access keys and implement the AssumeRole feature in conjunction with trust policies. This strategy enhances security by ensuring that temporary credentials are used, minimizing exposure to potential threats. These practices help in maintaining a robust identity management framework tailored to the requirements of both GCP and AWS environments. In conclusion, we've explored two methods of secure identity management that are designed to cater to different cloud environments, be it GCP or AWS. While each offers distinct features, choosing the right one requires understanding your specific organizational needs. Consider which platform aligns with your existing infrastructure and future scalability plans. As you move forward, it's important to practice using these tools in a secure and controlled environment to gain confidence and ensure accuracy in implementation. Additionally, stay informed by regularly consulting the cloud provider's documentation, as this will keep you updated on the latest features and best practices. For those interested in expanding their knowledge, here are some valuable references. First, the GCP documentation on service accounts and IAM concepts is excellent for understanding Google Cloud's identity management practices. Secondly, the AWS documentation provides insights into AssumeRole and AWS STS, offering guidance on Amazon's approach to secure access. Additionally, you may find it beneficial to explore cloud identity and access management white papers, which provide in-depth perspectives and best practices for managing identities across cloud platforms. These resources will support your understanding and help you apply what you've learned in real-world scenarios.